Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. Friends, in this session again we have new project and where we are going to create our own custom object detection model with the help of Roboflow, and then we are going to detect our object. Also we are going to create the counter for object. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, first just open Tony Python IDE, and first we are going to install a basic packages for our project. So just open Tony Python IDE, then go to the tools, manage packages, and search for opencv-python. This is what our first package, opencv-python. Search on PyPy. First package, opencv-python, click on install button and it will install opencv-python on our Windows 11 machine. Then of course we need Ultralytics package, so search for Ultralytics, click on search on PyPy. First package, just click on install button and it will install Ultralytics. Then we need CV zone package, so just search for CV zone and click on search on PyPy. First package, just click on install button, that's it, it will install CV zone on our Windows 11 machine. So this is how we need to install opencv-python, Ultralytics and CV zone package for our project. So for today's project I have created a new repository, and the repository name is custom object detection and tracking. I will mention the link inside description box. You need to simply copy paste the link inside the browser, then go to the code and click on download zip, and it will download our zip format repository. Done. Now simply open file manager, go to the downloads, and this is what our repository. Right click to the repository, WinRAR, click on extract as a folder name, and this is what our folder name. Again go inside the folders, again same folder. So here I have mentioned the full code inside main4.py, then we have tracker.py, and then we have custom model training Google Colab file. So first we need our video file, so let's just download our video file. For that we have here vid.txt text file. Just open it and copy the mega cloud link, copy it, open the browser, new tab, and just press Ctrl+V, paste the link, and it will open our video file. So this is what our video file. Click on download and it will download our video file. So friends, as you can see, we successfully download our video file. So let's just close mega cloud tab and close the text file, go to the download and cow1.mp4. this is what our video file. Just right click, cut, and move the video file inside our repository custom object detection tracking main, again same folder, and just paste the video file over here. So let's just first play our video file, then we will get the idea what basically we are going to detect. So let's just play video file. So here it is, as you can see, this is the drone view for cow. As you can see, we have here lots of cow, and if I continue to play the video, the drone is moving, and as you can see, this is what our video. So our goal is to detect all these cow. For that we are going to use Roboflow, and we are going to create our own custom model which detect cow. And then we have our tracker.py, so we can assign the ID, unique ID for each cow, and then we are going to create the counter. We are going to count all these cows. Simple. So this is what our video file. Let me start again, just go back, and if I play, so this is what our video file. As you can see, the drone is moving, and our goal is to detect the object, track the object, and create the counter. That's it. This is what our video file. Now simply, as I mentioned, we are going to use here a Roboflow. So we want to move cow dot mp4 file on our Roboflow. So just open the Roboflow. So let me open Roboflow. So friends, as you can see, I have opened the roboflow.com. This is the website, and just click on sign in. Of course, you have to sign up with your Gmail ID. So just sign up with your Gmail ID, and then here it is. As you can see, I have already trained all the images for same video file, but let me show you how to train the images for this particular project. So just click on new project and mention the name over here. You can mention any name, because we are going to use basically here YOLO V8 and segmentation model. So I will select YOLO V8 hyphen seg, and then annotation group, or I will mention here cow, and then of course we want to select here instant segmentation and create private project. Then you will see this kind of page where we want to upload or where we want to select our file. So here we want to just drag and drop our video file. So let's just open our repository and make like this way, and just drag and drop over here cow1.mp4 our video file, and by default it will capture 19 images from the video file, 1 frame per second. So just 19 images is more than enough. So just choose frame rate and it will capture images from our video file itself. Simple. So 19 images, as you can see we have 19 images over here. Done. As you can see we have all the images. So here simply we want to select start manual labeling. So just select start manual labeling. Then here you want to mention your Gmail ID, and then just simply click on assign to myself. It will assign all the images for your Gmail ID. Simple. That's it. Now just click on start annotating, and now this is what our main page where we want to start our annotating. Simple. So as I mentioned, we are going to create here a segmentation model, because we want to detect each cow. So if we select segmentation model, it will perfectly detect our object. So here simply first just click on bounding box tools. As you can see, this is this one, bounding box tool. Just select it and draw the bounding box on like this cow. Just draw it, and then here, because we mentioned annotation group already cow, so of course it will select cow as a class. Select it. So here it is. As you can see, by default the cow. Just click on save, and we draw a one rectangle on one cow. Now our goal, as I mentioned, our goal is to create a segmentation model. So for segmentation we want to convert rectangle in polygon. So simply here we draw a rectangle on this cow using bounding box tool. So we want to convert this bounding box tool in polygon. So right click, convert to smart polygon. As you can see, the first option, just right click to the rectangle, convert to smart polygon, just select it, and then as you can see it will automatically convert your rectangle in a polygon. Just click on save. Now same way for this cow, just draw a rectangle, right click, convert to smart polygon, save it. Now as you can see we have two cow, because we are converting our rectangle in polygon. That's why as you can see we are basically detecting a cow shape. Simple. So for this cow, as you can see, we are again going to draw a rectangle, right click, convert to smart polygon, just save it. For this cow, right click, convert to smart polygon, just save it. For this cow, just draw the rectangle, because we select a bounding box tool, so it will of course draw a rectangle on object. Then just right click, convert to smart polygon, save it. For this cow, right click, convert to smart polygon, just save it. For this cow, convert to smart polygon, just save it. For this cow also, just right click, convert to smart polygon, save it. So this is how you need to train all those images for 1 to 19. We have here 1 to 19. For each cow, just select bounding box, draw the bounding box, right click, convert to smart polygon, and of course it will take some time. As you can see, the model is basically detecting, so no worry, it will take little bit time, but it will convert the rectangle into smart polygon and just save it. So this is how I have already trained all the images. So you have to train all these images, or we can say you have to train all these objects. Means here we have cow, so you have to train all these cow shapes object images. Like as I mentioned, you have to just select bounding box tool and then just right click and convert to smart polygon and just save it. Done. So friends, as you can see here, I have already trained 2 images. Remember one thing, as I mentioned, I have already trained all the 19 images. This is only for demo purpose, that how you can use a Roboflow. Simple. So here, after training completed, you have to just click on add 2 images to dataset. So just click on add 2 images to dataset, then just click on add images. Done. Now we have completed annotation process. Now just go to the generate, and then here we want to click on continue, then augmentation continue, then create continue, and then here you will see this kind of page. So as I mentioned, I have already done with this process. So when you completed your annotating process, you have to just go to the generate, then click on pre-processing, then click on augmentation, and then just click on create. That's it. It will create our version. As you can see, this is the page, yolo v8 dataset, and here if you click on export dataset, it will export your dataset, which we can use inside our Google Colab training machine. So format yolo v8, and if you click on continue, so this is the code which you want to copy paste inside our Google Colab file. Simple. So now, as I mentioned, because I have already done with all these processes, so this is what my project here it is. As you can see, I have already done with all the process, and here export dataset. So now first we want to upload our Colab file. So let me open Google Colab. So friends, I have opened my Google Colab. Just click on upload, click on browse, and go to the repository, custom object detection tracking main, again same folder, and select the Colab file, and now it will upload our Colab file on Google Colab. So friends, we have successfully uploaded our Colab file. Just click on connect GPU. So friends, as you can see, we have successfully connected. Now we are going to simply run our cell one by one. So just click on first cell. Done. Now next cell, import OS. Now we are going to install Ultralytics. So just click on next cell. Done. As you can see, there is green color tick mark, so it means we have successfully installed Ultralytics on our Colab machine. Then we are going to import our packages which we just installed. Then we are going to cross check our yolo v8 and -sec model is perfectly working or not. So we are going to use here yolo v8 and -sec.pt model, and then we have here a doc.jpg image file from media.roboflow.com, and we have here basically, as you can see, the object one person one dog from the image itself. Just click on next cell, and this is the detection which we have inside our image. Now as I mentioned, now we want to just apply our Roboflow code over here. So just open Roboflow. As I mentioned, just click on export dataset. Here we want to select YOLO V8. So just we are going to select here YOLO V8. Then click on continue. Then it will show our download code. So just select it from Roboflow to YOLO V8. Just select it and then just copy it. Just open Colab file and remove the old code, delete it and press Ctrl+V. It will paste our latest code, and then just click on the cell. It will create dataset folder, and inside that it will upload all the images which we train. Done. As you can see, now if you click on this small folder icon, we have here dataset folder, as you can see, and inside that we have YOLO V8 folder, and inside that we have train and valid images, simple images. As you can see, we have all the images. Now here what we want to do, we want to just double click on data.yaml and we want to mention the path of train and valid folder. So train is basically this path, so we want to remove this old path for train folder and just copy the path. So train, click on here, copy the path and just click on here and press Ctrl+V. It will paste the path of train folder. Same way for val folder, remove the old path, just go over here valid, click on this 3 dot, copy path, just come out here, data.yaml file inside, select it val and just press Ctrl+V. It will paste the new path of valid folder. Then we want to save the data.yml, so just press Ctrl+S and then just save the file. Simple. Just close it. Now we are ready and we are going to start our training with 100 epochs. Just click on the next cell. As I mentioned, we are going to use here YOLO V8 and sec.pt model. So friends, as you can see, our training is started. It will take some time. Meanwhile, I will pause the video. So friends, as you can see, we have completed our training process and our model is saved inside runs, segment and train folder. So go to the runs, segment, train, weights, and then we have here base.pt. Just click on this 3 dot, click on download and it will download our base.pt model. So friends, as you can see, we have successfully downloaded our base.pt model. Now just open the file manager, go to the downloads, and this is what our model. We want to move our model inside our repository, so right click, cut, go to the folder, again same folder and just paste the model over here. So as I mentioned, I have already created a full code for this project inside main4.1.py. So just click on main4.1.py and it will open our code like this way. As you can see, our all the modules which we imported, and then base.pt, then cow1.mp4, and here we just want to create our custom text file, for custom label text file, coco1.txt. so just open our repository and here where we just copy paste our model, just right click, new and text document and mention the name coco1.txt and open. Just click on coco1.txt. it will open the coco1.txt as a normal text file and mention the class name. We have only one class which is cow. File, save it, done, just close it. So we create coco1.txt file also, and then this is what our detection, our basic object detection. This is what our basic object detection. We have here rectangle coordinates x1, y1, x2 and y2, and then as I mentioned, because we don't want to detect only the object, we want to track the object. So for that we have our tracker file, here it is, as you can see, tracker.py. So from tracker.py we want to send our detected object rectangle coordinates to tracker.py. Tracker.py again track the object and it will assign a new rectangle coordinates to the object, also it will assign the unique ID for each object. So here it is, as you can see, bbox list tracker.update, and here where we detect our object. So we have x1, y1, x2, y2. This is the basic object detection with the help of YOLO v8. And then for tracking, we want to send these rectangle coordinates to our tracker. For that we want to create here a list. So list.append, and inside that we are going to pass x1, y1, x2 and y2. x1, y1, x2 and y2. And here it is, as you can see, I have mentioned the list. And then we mention here our tracker. As you can see, we mention here tracker is equal to tracker. So tracker is basically the class which we have inside our tracker.py. So let me open tracker.py, then you will get the idea. Tracker.py, this is what our tracker.py. As you can see, we have here class T is capital, so which we call over here. As you can see, T is capital, and then we just mention here tracker as just a variable, and then this tracker represent our tracker, T is capital, and then we are going to call our tracker over here, as you can see. So bbox list is just a variable, then we have our tracker variable, and inside tracker class file we have update function. So we want to use that update function over here. So tracker.update and just pass the list. Now it will send detected object rectangle coordinates to our tracker, and as I mentioned, now we are going to use for loop for bbox in this bbox list. Again, tracker will assign new rectangle coordinates. For new rectangle coordinates we want to assign new variables. So x3, y3, x4 and y4, this is the rectangle variables new, and then we have new variable which is the ID, which we are going to show on rectangle top left corner. So all this represent basically bbox, not represent, basically all this is basically our bbox. Simple. Then we are going to use here a center point because we want to create a counter. So let me first show you the detection and the tracker, and we have now a unique ID. So what we are going to do, we are going to simply comment some code, and now we are going to only detect our object, and then let me copy paste this rectangle and circle code over here, and then we are going to go for a next code where we are going to create a counter. So let me comment all this line, and then we have here a counter also. So I just want to comment all this line also. So that's it, and cv2.line also. Let's just first go with only detection and tracking. So we have here, as I mentioned, we have here now our basic object detection. So now because we want to create a tracking, so we want to send our basic object detection rectangle coordinates to the tracker, and then tracker will assign unique ID. So this is what our first object. So this is what our first goal. So now we have all the done. Okay, now simply let me show you here, because we are going to go one by one frame. So let me mention here a 0. So if I start the code, just a minute, there is no rectangle. Let me check here. Okay, so I have mentioned here cvism put text rect method. I need to mention this rectangle method also. So let me copy and paste the rectangle method also. Save it. Now again run the code. So friends, as you can see, we are perfectly detecting each cow separately. It means our segmentation model is perfectly working, but we are not going to segment all these cows. we are only going to use our segmentation model, and we are going to use here rectangle method. There is no need to create here a segmentation. So for that I have mentioned only the rectangle method, as you can see. So each cow we are basically detecting separately, and we have center point. As you can see, for this cow we have red color center point. So for center point we mention here cx and cy. So cx and cy is basically x3 plus x4 divided by 2, and cy is basically y3 plus y4 divided by 2. And of course, if we want to draw a center point, so we have our cv2 dot circle method. So this is the basic method, cv2 dot circle. This is how we always draw a circle frame, and then cx and cy, this is the radius, this is the color, and this is the, because we want to fill the circle, so simply mention the -1. Then a rectangle method, x3, y3, x4 and y4, and then we are going to put this id on each rectangle top left corner. So our rectangle top left corner, of course, x3 and y3, as simple as. And then we have our result. Rectangle, for this cow we have 0 is the id. For this cow we have 4 is the id. For this cow we have 1 is the id. For this small cow we have 6 id. For this cow we have 5. For this cow we have 3. For this cow we have 9. So as you can see, we detecting basically each cow separately. If I am now continuously skipping the frame, and then we have basically all the cow detection. Let's just start our while loop. Let's just start our while loop. 1, save the code, and if I run the code, so as you can see, we have detection, we have rectangle. Now the drone is moving and we are basically detecting each cow separately. There is a unique ID for each cow. There is a rectangle. Because we use a segmentation, that's why it's perfectly detecting each cow. Simple. For more perfect detection, you can use more images and you can train a perfect unique model. So we have done with detection, we have unique ID, and then we have center point. Now we want to create a counter. Simple. So for counter we are going to use a line method. So how to draw a line on the frame? Simple. For that we have here our cv2.mouse event move function. So let me again freeze the frame. So I will mention 0 over here. Save the code. If I start the code, so because we have here cv2.event mouse move function, so when we move our mouse cursor on the frame, inside shell we have xy coordinates. So this is what our friend. So as you can see, xy coordinates, mouse cursor xy coordinates. So let's just say if I want to start the line here, so we have x coordinate, because if you want to draw the line, we need start point xy coordinate, we need end point xy coordinate. So this is what my start point. So start point xy coordinate, inside shell at the end we have 0499. So this is what my start point, and if I want to end the line over here, so this is the end point xy coordinate, at the end we have 1006 and 482. So this is what my start point xy coordinate and end point xy coordinates with the help of our cv2.event mouse move function. So I have already draw here a line, as you can see. So now we are going to uncomment our cv2.line function. Now we have a line on our frame. 5487 is the start point, and then we have 1019487 is the end point. As you can see, this is what our line, pink color line. Remember one thing, you need to mention the start point y coordinates and end point y coordinates always same. If the start point y coordinates, it let's just say 480, so you have to mention end point y coordinates also 480. So here it is, as you can see, I have mentioned 487 and end point y coordinates also same 487. So now what is the what is the idea? So when this line, of course the drone is moving, so when this each cow center point touch the line, we have detection, we have a counter, also we have unique ID. So for that we are going to mention here CY1. So CY1 is basically 487, our y coordinates. Here it is, as you can see, CY1 is basically 487. So mention the same coordinates, same number 487, which is CY1. CY1. If the y coordinates is 480, so you need to mention CY1 is basically 480. Then offset is equal to 6, and then now we are going to create our condition. If now there is no need to detect our object before we match our condition, so let's just comment our detection, because now we want to detect our objects after we match our condition. When the each cow center point touch our line, then we want to detect our object, then we want to show the rectangle, the unique ID. So for that I have comment the detection. Now we are going to uncomment our condition. So this is what our condition. If our CY1, this one CY1, if CY1, if it is less than CY, this CY is basically center point. As I mentioned, our idea behind of the counter is basically when the object center point touch our line. So if CY1 is less than our CY center point plus offset, and CY1 is greater than CY minus offset, which is our condition, then we are going to detect our object. So then we have rectangle, then we have circle, then we are going to put the ID on each cow top left corner. Now just start the code. I have saved it, and if I start the code, and as you can see, there is no detection, there is no rectangle, there is no center point, there is no rectangle. Why? Because the rectangle center point is not touching this line. So if I skip the frame, because it will take some time, because when we start the video the drone is still there in still position, it's not moving basically, so we need to continuously skip more frames, or we can simply start our while loop, it will better. So if I start the while loop, now you will get the idea. As you can see, now there is no detection, but when the drone is moving, of course the frame is going down, and as you can see, when the cow center point touch, there is a rectangle. As you can see, for this cow, the line and the center point touch, there is a detection, there is a unique ID. There is a detection, there is a unique ID. 12, 15, 16. So we successfully mention our condition. When the object center point touch our line, then only we want to show our rectangle, our unique ID, and our detection. Now it is really easy to create a counter, because we have our condition. So we can simply say when the center point touch our line, we want to save our ID inside the list. So here it is, our list cow count dot append, and we are going to save our cow count over here. So here I just want to mention, as you can see, I have mentioned the cow count. Cow count is the list, and inside that, when our condition match, cow count will save the ID. And because it will take some time, when the center point touch the line, it will take some time to cross the line, so it will basically count the same ID again and again. This is the error. So for that we need to create here a condition, please don't count same ID again and again. So if cow count is the list where we are saving the ID of each cow, so if cow count dot count ID is equal to 0, means don't save same ID again and again. So it will not save same ID again and again inside the list. Then we have counting is just a variable, and length of cow count is basically our list, is basically the number of counters. So now we are going to simply put the counting as a text on 50 60 coordinates, and 2 and 2 is basically the rectangle and text size. Simple. Save the code, and if I run the code, now we have counter on the frame. As you can see, still 0 count. So when drone is moving, the counter will 1, then 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. As you can see, we are counting each cow separately with the help of Roboflow segmentation model. We create our own model, we assign the unique ID for each cow using our tracker, and then we create our counter with the help of cv2.line method. We mention the condition. Our condition is what? When the object center point touch our line, then we are basically saving their unique ID inside the list, where here we have cow count is the basic, but the list where we are basically saving the unique ID, and then the length of cow count is basically our counter. That's it. So I have mentioned the full code. I have shown you the method how you can use the Roboflow for creating segmentation model. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.